Hello everybody, welcome to this new live stream where we are creating an entire game in C from scratch. Well, if you have been following along, you saw a lot of progress, especially in the last couple episodes where we started focusing on the gameplay part, like improving the feel, improving the animations, adding particle systems, all that sort of crazy stuff. So we got to a pretty solid idea of what the gameplay is going to be for the game. And in case you haven't been following along, you can go to my YouTube page and see all the past episodes. So you can watch ever since from the first line of code that we typed all the way to where we got, which is pretty cool. Let me show you the game, how it's running now. So we start out with a small breakout clone. That's the base idea. And then we quickly started, playing around with the game modes. And the idea of the game is, what if Breakout was the only arcade game that you were supposed to have? So all other arcade games would be Breakout based games, like this. This one is Pong. Got pretty hectic for a moment there. So. And we got Space Invaders as well. And we're going to do a lot more. So that's the base gameplay. We're going to explore all sorts of other games. I was thinking about at least like Tetris, Donkey Kong, and I don't know. We can think about all sorts of crazy games that we can do, right? But in order to do that, we're going to spend some time now making the engine a little bit more robust. So. And if you want to follow along, you can download the game and its source code for free on itch.io. So you can just come here, danzaydan.itch.io, and can download the game and the source code. I just updated the page with nice GIFs. Yeah. So that's it. Let's start programming. So this is what we're going to do. We're going to take a step back and focus a little bit more on the game engine so we can make it a little bit more robust to make some cooler things. So a couple of things that we noted that we wanted to do in terms of like rendering was RotatedRect and bitmaps. So I think I'm gonna pull that, and possibly also going to do like sub-pixel accurate rendering. Can maybe do that. I don't know if we're gonna get to all that today, but let's just start doing it. So the basic idea is we have right now the Windows platform layer, which allocates a pixel buffer like this, and the game has access to it through this render buffer struct. And we created a rendering system, really basic, that can do like all sorts of operations. Like we can draw rectangle in pixels, we can draw a transparent rectangle that we added like doing a lerp, and yeah, then we do like pixel independent stuff, like moving from pixels to world and world to pixels, and that's about it. Yeah, we also did like some helper functions as well as this hacky thing to draw number. So what we want to do now is we want to do like a draw rotated rect, correct? And right now all I'm gonna do is copy from the RotatedRect, and then I'm going to start, changing that a little bit. And you know what? I'm also going to get the RotatedRect in pixels, just so everything is here. So this is like in pixels. We first transform and then we rotate. RotatedRect, draw RotatedRect. And we're going to take a point, half size, and the angle. And let's do like in degrees. Okay, so that's the basic idea. And now let's just call this function so we can play around with it. So draw RotatedRect, and we're going to pass 0, 0 for the position. Let's do 3, 3 for the size. And let's animate. Yeah, let's do like a angle dt, angle, and the color. Let's do like white. Static int. Okay. Static float. Pardon me, kind of slow start. Okay. Now we should have nothing. I mean, just just that rectangle. Now let's start playing around with that. We need a couple things first. We are going to calculate where are the vertexes of the rotated rect. So we need to, so our base points are these guys, right? But in fact, let's do them on float. Then we're going to convert that in integer later on. And then we can do like integer versions of these guys. And let's see. Then we're gonna clean this up, but just to get started, let's see. I1 here. And okay, let's see. Conversion from. Okay. We're going to do more elaborate things than just this cast, but one step at a time. Okay. Okay. Looking good. Hey Marcus, nice to see you again. Today we're gonna tackle some, graphics programming, and let's do some like RotatedRect, bitmaps, maybe subpixel accuracy stuff. So first of all, we have to calculate. We have the points, but now we have to rotate them. So that's the basic idea. In order to rotate, we're going to think about it as a matrix transformation. A rotation matrix is just basically the cosine, the sine, that's for the x-axis, and then a minus sign, and then we have the cosine here. So we're going to multiply by this matrix, or we can just like do, we can do like individually the points as well. But I think it'll be easier just to construct these matrices. Then we can like optimize later on if we feel it's necessary. So in math, let's do a matrix 2 by 2. Okay. Let's do M2, and then union, let's say of 2 by 2. This guy, and then let's do like, and then we can like specify the orientation a bit better. So it's going to be, in terms of memory order, let's do like 0, 1, and then 1, 0, and then 1, 1. Can play around with that. So the thing is, transform. We want to build a matrix like this. Math. Yeah, well, we are in for some math today. Hopefully, it's not going to be like too crazy. Let's just create like an identity matrix for now. And yeah, I don't think it's gonna work. Yeah, transform. No, it did work. I love math. Okay, so maybe you're gonna help me today because, oh, you said the good sense, right? Because we're doing some nice math today. First of all, we're just going to multiply these vectors by this matrix. Let's do like a v2, like inline v2, mul m2 v2. I'm going to take a matrix. I'm going to take a vector. Okay. So the resulting vector is going to be, so that's just a quick reminder in terms of matrix multiplication. Let's say this A, B, C, D, and then we have, that was pretty bad drawing, and then we have X and Y. So the result is going to be like X, AX plus BY times C, XC plus DY. Okay, pretty easy stuff. I'm gonna put it in here in the size. Okay, so it's v dot x times m dot 0, 0, right? And then we're going to do plus v dot x. Yeah, we're going to do v dot y times m dot 0, 1. Yes, I think that's correct. And then we're going to do the same thing, but with 1, 1 and 1, 0. Okay, and then we can just like return. Yeah, and now we're going to create these vectors. Maybe I can just like inline them here. So I'm going to like move. I love the cross product. Well, since I haven't done much 3D stuff by hand, you know, with no engines and no libraries, I haven't gotten much to the cross product part. But the idea is pretty cool though. So, but I just haven't. I don't have much practice implementing operation that involve the cross product. Maybe you can tell us a little bit of the story about some cases you program with the cross product. That can be pretty cool. So this is the transform and this vector. Okay. Yeah. So we should have the same thing, right? Because we're passing the identity matrix. And convert from F32 to V2. Yeah, I'm gonna have to. Oh, okay, we're gonna have to build this individually. So, I'm sorry, not individually, as a whole vector. So we're gonna have like, let's do like the min, which is x0, right? And then we're going to do y0, which is this guy. Okay. And then I have the max, which is same thing but plus. Yeah. Okay, and now we're going to do min.x, max.x, min.y, max y. Min redefinition. What do you mean min redefinition? Oh yeah, that was stupid. Max. Okay, now let's see if nothing changes. Nothing should change. Okay, nothing changes. Now, let's start playing around with that. Let's play around with the matrix. Okay, so we should do the transform before we apply these guys. And in fact, I may just apply these guys in the matrix. Thinking about it, yeah, like, or maybe we can do like apply the scale by hand first. Yeah, we're eventually going to do everything on the matrix, but for now let's just do one step at a time. So this is going to be min.x, min.y, and then max. So like clean up, do everything on the matrix. So, okay, now we have a bigger rectangle. Okay, so now we're set up to do some matrix transform. In fact, let's just take the time and do that. I'm not sure if I can just multiply like here and not do that there. That may be it. But I'm still doing the half size. Yeah. And then I don't need to do this as well. Yeah, that's gonna be way better. Let's see. Okay. So yeah. Let's call like A. Or maybe S for scale. Yeah. Okay, way better. And then we can clean this up later on. I'm not sure we're going to do like homogeneous coordinates for the position because this is enough just to add it later. Although maybe we could be smarter about this addition. Yeah, let's do like a offset vector, like a position vector V. Yeah. And then I'm going to do just this. Okay. Height. Yeah. And then min is going to be add v2. Min position v, same thing for our max. Okay. Nice cleanup. Now we're going to transform into pixels. Well, let's see if nothing changes. Okay, so we messed that up. Oh yeah, okay, here. Easy enough. Small typos. Okay. Now let's play around with the angle. First thing, we should transform the angle to, let's say, from degrees to radians. Okay, so we need that in math. Not sure where to put it, maybe up here. Direct to red. Then we're also going to like define pi. Let's see pi. Yeah, they don't give us pi 32. Let's just take the whole thing. Let's get more decimals. Yeah, this looks enough. Okay, so this is going to take angle, and it's going to return. I always get this wrong. Maybe clone style can help me. In order to convert from degrees to radians, I have to divide by 180 and multiply by pi. So maybe I should just, yeah. Is this correct? Let me see. If we have 90, let's check this out. If we have like 90 divided by 180, yeah, times pi. Yeah, okay. Looks about right. Now, we have to make this matrix that's just scaling now. We should make this a rotation matrix as well. So, like I said in the first part, I think I drew on top of that. We have to calculate the cosine and the sine. And then we have to build like the other matrix as well, and then multiply them together. Yeah, this is like the scale matrix. Oh, maybe we should. Yeah, let's do the matrix multiplication. Then we can do like later on we can optimize that as well. So this is the scale matrix because I'm not sure. I'm pretty sure I can't. Well, I don't know. Let's check out. Let's do the transform matrix. Okay, so the idea is this is the sine well, I wasn't expecting this to work. Do we have the library? Maybe Windows uses the library. Yeah, I'm not sure. Okay, so let's just try the rotation. This should be like cosine. This should be the minus sign. This should be the sine. And this should be the cosine. Well, I'm not sure what's gonna happen. Okay, we have a tiny guy, and doesn't look right. Should really be tiny because we stopped doing the this guy, the angle guy. So let's just increase the size for now and not worry about the scale. But we are going to work on that in a while. So we're not adjusting for scale. Okay, we have some movement. It's just... Oh, in fact, this shouldn't be working. What should be working though is that we should know the min and max. That should work. So we're going to do a draw rect on the points, right? So we're going to do a min as well with let's just do like a half size, like a p half size. Okay, I way too much ahead at that point. Have to do slowly. So let's do like 1 by 1, and then we can do p half size, and then we're going to do like, let's do orange. Okay, so we're going to draw the min, the max, as well as the other points, right? Which is like the min, the max x with the min y, and the other way around. So I want to see the points that we are considering, right? Again, I see nothing. Yeah, this has to be later though, after we draw this guy. Okay, and I still see nothing. So let's go back to the good old scale and see if our point rendering guy is correct. Oh, sorry. Just like this. Okay. So I don't see the points. Maybe I should make it larger. I'm drawing that at the min and the max. Oh, but it's in pixels, this guy. So maybe I don't want to do any yeah, I don't think I'm gonna do the pixel transform at that point. Not sure. Since this guy is just a debugging guy, I'm just going to like debug min and do a debug max. Then min, max, dmax. Okay. Okay. But let's see. Let's go back into multiplying this. Okay, this is a 30 by 30 rectangle, but these guys are wrong. I think I'm gonna debug just to make sure we are getting what we expect at this point, before we actually do the sine and the cosine. Okay, so we get, oh, probably have to turn off the optimized flag, otherwise we're going to have the instructions all over the place. So only when we are optimized we have the library, the CRT. That's certainly wrong. Maybe, I don't know, that's a Windows thing, but we are going to do like can include std, I don't know where is cosine defined, crt cosine f, std cosine f. Let's see if someone shows me where it is in which include file. Math. Yeah, well, yeah, just math.h. Okay. Yeah, math.h. I don't know. My brain was pretty dead at this point. Okay, so let's go back to the debugging. Okay, so we have. I'm sorry, I read the wrong guy. I totally feel you there. Yeah, thanks. So P0, half size is 30, angle doesn't matter for now, and color. Okay. Aspect multiplier, the size, okay, the angle. So we calculate the cosine and the sine. And look, right? And then we do the matrix. Now, we are creating the, yeah, let's see, we're multiplying, let's see the minimum. The minimum is like minus 204, and this guy is plus 204 pixels. And then we offset that by the center. Yeah, I think that's right. I think that's right. Yeah, but we're not getting the correct display there because we shouldn't really do this at this point. We first should build like the min and the max without transforming. Yeah. And then we should copy those, which are like in, yeah. At this point we are still at unit space, but we're just calculating the correct points. So we do this guy and this guy. Let's see. Okay, nice. So this is what we expected. Now this is pretty huge, right? Let's do like 1. So we have the points. Now, if we go back and do our sine and cosine here, I think I'm gonna do 2 matrices. Yeah, let's do like a scale matrix and a rotation matrix. Then we can optimize that later on. But then this guy should really be multiplied by the rotation matrix. And yeah, and then we copy to show the points. Yeah. And then at this point we do the scale. Vector pixels. Yeah. Okay. Declaration of scale. We already have scale. Let's do like scale transform. Oh, we actually have a global scale. That's pretty bad. Rotation. Let's rotate. Let's do rotation. And then let's fill this up. Cosine, sine, minus sine, and cosine. Okay. Now let's see what we have. Huh? Still not working. Okay. Now let's go back and debug. Now that's somewhat nicely structured. So our angle is pretty small. Let's just pass like a known angle. Let's pass like 45. Let's firstly see what we have. Yeah. Then let's calculate. So 45 is 0.7, I don't know. Let's do like 45 degrees in radians. Okay, so this what? It's not correct. 45. Oh, okay. No, this is correct. I was looking at the wrong value. And the cosine and sine, they look correct. And we're building the rotation matrix. Maybe we got these guys wrong in terms of position. Okay, so we built the rotation matrix. Okay, then we multiply, we create the minimum, which is p minus half size. Then we multiply that by the rotation matrix. And let's see if this is correct. So, yeah, see, it's not correct in terms of the memory order. No, it is correct. Pardon me. It is correct. No, I'm getting all confused now. This, our matrix looks like this. Okay. Now, at this point, when we do the multiplication, we are doing the first guy, which is like the sine, and then this guy, which is the cosine by the x, right? Let me draw that again. So this is sine, sorry, this is cosine, this is sine, this is minus sine, and this is cosine. So I suppose we were correct, right? We're doing x 0, 1, like 0, 0, 0, 1. Yeah, 0, 1 should be minus, so we were correct. But let's see the result min. Yeah, let's do the max. Let's see. So this is our matrix, and this is our vector. We're doing 30 times this guy. Oh, yeah, okay. Plus 30 times this guy. Actually, what do we expect? We expect this, right? So we do expect some of them to be 0 in the, yeah, 0, minus 42, and this one is 0, 42. So you know what? That kind of looks correct, to be honest. So, and this guy is going to be 0, minus 42. See, this is wrong. This is wrong here, our drawing thing. So our 4 points are actually, man, you're nuts, making a game from scratch. Is it hard? Someday using it or something else. Good night. Good night, man. Thanks for dropping by. I have used engines in the past. I have used Unity for a while, and then I shipped a game using Unreal for the PS4 and the PC. I spent like 3.5 years working on that game. So I have been using Unreal for 5 years, and I know, kind of got tired of it and started doing some engine programming. Now we're doing a game from scratch on a live stream. That's the thing. That's the hardest part, because I have to do like these structured things, and there's a little bit of pressure also. But we are coming along. Like if you see the game, just ignore those yellow points. We have a pretty cool breakout kind of game. Let's get the power up levels from scratch, and I recorded everything on stream, so you can watch like from the very first episode all the way to, you know, what we have now, and hopefully to the game's release of sorts. Yeah. Okay. Oh, I kind of clicked away. Okay. So I suppose this is wrong. Let's go back to the rendering. This is wrong. So if we have this as the min and this the max, the other points are like this one. Let's say this is like 0 minus 40, right? That we got, and this is like 0, 40. This guy's supposed to be 40, 0, or minus 40, 0, and this guy's supposed to be 40, 0. So yeah, it's the other way around. This has motivated me for going back. Thanks. That's awesome, man. That's like the goal, man, of these streams. I mean, you guys should also pick up a few things, like learning some new things, but also, you know, just start doing. I was motivated by people doing streams as well, so that's awesome. Nice to hear. Okay, so this is the part we got wrong. So we should also get these guys inverted, right? We're gonna have to think about that a little bit more. Let's just see a more correct result. So I really should stream again. Yeah, absolutely. Absolutely, man. Streaming is really cool. It's a different kind of challenge, right? Because we do like programming for reals during the day, and yeah, sometimes just cool to see. And I'd love to see that, like some math-related stuff, clone style. Since you said that math was your thing, maybe I could learn a thing or two on your streams as well. So we are correct. Let's just speed this up like a lot, like times 5. Okay, so we are correct. Let's speed up even more, and let's just decrease the size. Just got learning. I just love learning. Yeah, and that's what you gotta do, man. I mean, you don't have to be great at it. If you love learning, you're gonna be great at it eventually. So, I don't know, just like engine programming, right? This is also a learning experience for me. I mean, I did like big commercial games using engines, but without engines, this is like the biggest game I'm making. This is a breakout, guys. So, yeah, all you have to do is keep learning. Okay. Also, the points, they rotate. What? Oh yeah, the point, man. That's what we're doing. So we got the points, and that's like the base of what we needed. Now, all I have to do now is to check these guys here, whether they collide or not. And in fact, I should just do like draw Rects in pixels, so we can go back to the single matrix guy. Okay, so let's just review what we got here. It's starting to get confusing. So we receive all this info, right? Then we do a couple of matrices. We do a scale matrix, and this is like the this is really the world to pixels scale transform. And then we do a rotation matrix. So this guy, I'm going to do it like down here for now. Yeah. Like, yeah. Okay. So first out, we do our local transform, or object transform, let's call it that, and calculate the min and the max. Okay? And then we change these guys to pixel coordinates, like this. Change to pixels, and these are in pixels. So then we clamp the pixels, and then we do the thing. The basic idea that we should do now is if we should do like a collision detection for the pixels, which are like, let's just try to draw a decent guy here. Okay, so let's say this pixel is a point here, right? All we need to do is see if it's inside this rectangle or not. We have done collision in the past. We've done let's see, collision. We did this colliding thing, which was the AABB versus the AABB kind of guy. So the question was, if we have a point here, is this guy colliding? And we just tested if it was greater than the min and smaller than the max for all the two axes. OBB. We're going to do OBB, right? which is yeah, oriented bounding box. I don't know if there's things such as OOBB, maybe object. No, yeah, I think it's just OBB, oriented bounding box. That's what we're gonna do, and yeah, it's going to return a bool, and we're going to see like this. We're going to do like OBB, point versus OBB, and I should really do like AABB versus AABB. This guy. Yeah, I think we started out as that, and then we went back. Okay, so point versus OBB. What do we have? We have a point, but the thing is, this is like a pixel coordinate. So this is really like a point. No, this is really I'm not sure if we should do this like in floats or not. I think this has to be a float anyway. So let's call that P. For the OOBB, we should really like pass a rect, like a let's call like a rect 2, and the rect should be like rect 2, and the rect should be a you're right, just OBB. For some reason I had to remember that. Yeah, OBB. It's gonna be cool. So we need a rect. A rect is going to be a, let's say, 0.0, 0.1, 0.2. Maybe we could do like an array of points. 4 points. Yeah. It's colliding. It's going to be ABB versus ABB. It's colliding again. Okay, so for now we have a rect, and this guy. Let's see, where do we create? Yeah, I had the max min. Let's do like a make rect max min. We do have some cleaning up ahead of us. Rect. Make rect. Should be like make rect 2. Max min, and then we do this guy. It's like rect result dot p0 is the min, and then we do let's say, yeah, min dot y max dot x. I think this is correct. I can do like slowly later on. This is the max and the min. Okay, so we have our rect, and this guy I can just do like rect dot p0. Okay. 1, 2, 3. D. Yeah, don't do that. O. We were actually doing that with the D min guy. So yeah, let's do like this. This is like really stupid, but this is just for debugging purposes. Okay, let's see if we are in the same shape. We are. Oh, actually we are not. We only see 3 points. 1, 2, 3. So maybe this is wrong. Yeah, this is wrong. Okay. Let's see. Okay, we're back to normal. Now we have the rect, and we can now work on our rect versus p versus rect, OEB. So the basic idea is, let's say we have these points. If I subtract these guys, I have an axis like this. Same thing for this other guy. So I can find out the axis just by doing this. But we do have the axes. They are these guys. So maybe I should not make that a general guy. You know what? I'm not going to do like the point. I'm going to do a little bit lower. So I'm going to have like the x-axis. And the x-axis is going to be cosine, sine. I'm going to have the y-axis, which is minus sine, cosine. Okay? Now, yeah, well, let's just keep the matrix for now. I don't know if we're going to keep that later on. Is the sine cosine? Yes, we are using the math standard library for that. So this is the first library. We are probably going to use like another one for image, but yeah, I don't see like the value writing our own sine and cosine stuff. I don't know, but yes, it is. Okay, so we find the cosine and the sine, and then we build. Let's just see if we have the same thing. We do. Okay. So now, since we have the axes, we can do the rotation a little bit easier. So we have the axes, and first of all, let's go back and do like for every pixel, right? Let's do like render buffer dot height, and then let's do like render buffer dot width. And now this should be like the collision test, right? Like if the P like is colliding, right? This should be the collision test. So it's going to be pretty much like if the P, same thing here, right? If the Px is greater than the min, we should really call that Minimax, I think. Yeah, let's do like, we do have Minimax. So min dot x, I think we got way ahead of ourselves doing all those rect things. Kind of got excited. Okay, so if the p dot x is larger than the min p and smaller than, we should really do like larger and equal, and it's smaller than the max, and the y is larger or equal this guy and smaller than this guy. Okay, this is the basic thing we want to do, but we are probably going to have some conflict in units, and we're going to have to solve them later. Let's see what we have. Yeah, we see nothing. It's probably the unit thing. So we are here in pixels, correct? And we should really focus on these guys, right? The minimax that we calculated based on these guys. So this one is the ix0, and this one is the ix1. And the minimum is y0, and the max is iy1. Is this not correct? Well, if we take this out, we should have like the whole screen right. Let's see. And we do. And then we crash. But we do have the whole screen right. Yeah, okay. So, oh, we're testing p.x. That's really stupid. We should test like x, which is like the pixel coordinate. Yeah. Okay. So we're doing that in pixels for now, and we have the same thing. Now, instead of doing like this calculation like this, in effect, I'm going to do like if x minus the min is greater than 0, and if the x minus this guy is less than 0, just organizing the code a little bit for us to make the jump to our rotated rect, which is the whole point, right? Okay, so let's just check out the code. And we broke it. Yeah. Okay. So this is the thing that we want to change now. Why are we doing this? Let's draw. Right now, we have a, let's say a pixel. Let's say we have like 15.7 in terms of pixels, right? And we want to draw like from 10, let's say 10, 5 all the way to 20, 10. Oh, this was like 10, 10, 20, 5, 20, 10. Okay, so what we are doing is just like subtracting this guy from the min, which is 5, and see if it's greater than 0. So if it's on this side, and then we do the same thing for this guy. But we can do it like this, because we know this axis is aligned, correct? So we can just pretty much test like this. If our axis is not aligned to this guy, like if we have like, let me put in a different color. If we have like this, what we really want to test is the dot product of this guy with the axis, which goes from like 0 to like 1 here, and more than 1 here, and less than 1 here. If it's positive, it means that it's on this side, and in this case, if it's positive, it's this side, and then we do like the whole thing. If we do like for the 4 guys, we pretty much make sure that we are enclosed on this rotation. Okay, so that's the basic plan we're going to do. So this is what we have to change, and I'm still not sure we should do that in pixels, but well, in pixels I mean in integer, and I don't think we do. So we are going to do like pixel p, and I'm just going to round. Yeah. Now this is going to be like x and y. Okay. So we have the pixel p. And I can just take out that warning. It's really annoying. Yeah, I know it's not initialized. I am in the process of using it. Okay. So we've had the pixel p, and now all we have to do is calculate how much it is on each axis. So let's say, let's call that projection 0, correct? And the projections, let's do like projection, yeah, let's call it projection 0. So the projection right now is just this guy, which is like pixel p.x minus this guy. And I don't think I'm going to do that on a pixel now. So this is going to be the min.x. Okay? So Okay, no, this is okay. So this is the same thing, right? You can go back. I think I'm gonna do like step by step again. So projection 0, projection 1, projection 2, and projection 3. Okay. Okay, so the 2 is gonna be this guy minus the max. This is min y and max y. Okay, let's see if still we have the same result. Is for coder free? There's a free version, which is the one I am using. You can go to each, I think it's, yeah, for coder. You can go to each.io and search for coder there. Let me see, for coder. Yeah. And you can download the free version here. And it's pretty complete. All there's lacking is the customization layer. So if you don't want to do like, and you can do like everything you want, like you can change the whole editor. But if you don't want that, you can download the free version. But the paid version is like $12. So it is similar to Vim or more Emacs. It's more like Emacs, but I think it's more intuitive than Emacs, a lot more intuitive. But there are a lot of customizations to make it look pretty much like Vim in a lot of different ways, or even Emacs. Yeah. Emacs, I also thought it was pretty bad to me when I used it for a while. I didn't like it. Okay, but yeah, so for code is not like Emacs. It's different. But I don't know, I think it's more like it. Okay, so I don't remember if you got it working. We got it. So it's the same thing now. So what I'm going to do is I'm going to change to test everything if everything is greater than. Because remember, the idea is to use the dot product for everybody, and I'm going to test if that's greater than 1. So really step by step. So if it's greater or equal to 0, but now we have to change the sign of these guys, right? So it's basically inverted like this. Do you play drums? I do play drums. You can see I have pretty cool. I bought a acoustic drum, but since I live in an apartment, I can't play acoustic drums. So then I converted that drums to an electronic one with a muted, I don't know, mesh heads and with triggers. So that's pretty cool. Yeah, there's a hi-hat. The hi-hat is let me see. The hi-hat is the electronic pad. You can also see one here. And it works pretty nicely. And it was pretty cheap to convert instead of buying the best electronic drum set I could know, because those can get pretty expensive. So I did the conversion, and I'm pretty happy with the results. Okay, so yeah, same thing. Now we're pretty much ready to change what we need to change. And what we need to change is this guy. So instead of just subtracting the pixel to this guy, which is like, let me go back a bit. Yeah. Instead of just subtracting the pixel, we subtract like 15 to this guy and get 5. Instead of doing that, we are going to get the dot product of 15 projected on this guy. Okay? And this guy, well, we know what this guy is. This guy is just like 0. Is that correct? Yeah, this guy is this guy minus this guy. So yeah. So we're going to do we have the dot product? I don't think we do. Math dot. Yeah, we don't. So for vector, let's do like a line f32 dot vector. 32. Maybe I'm thinking, doesn't math.h have dot product? Thinking of the OpenGL. I'm not sure, but I don't like using this for everything. So just for sine f and cosine f. So yeah, okay. So someone says no, so it doesn't have. But even if it did, these kind of math operations is nice to write by ourselves, just so we know what actually goes on, because that's pretty important to learn. And since one of the goals of this project is just to learn, it really does make sense to at least know this kind of stuff and like how to use it and how to. You mean the matrix multiplication? Yeah. Yeah, we haven't written a matrix versus matrix. We did like a matrix versus vector. Okay. So what I'm going to return here is a dot x times b dot x plus a dot y times b dot y. Okay, so that's it. Now, this guy is going to be the dot product, and we have to make sure this is correct, of the pixel, the whole pixel, with the rect v2, rect 1, and rect 0. So this is the basic idea. We have this guy minus this guy, which gives us this guy. And then we project this guy onto this guy, and that's going to tell us if we are on, let's say, this side or this side. Okay, illegal for struct. What's illegal for struct? Yeah, rect.p. Oh, yeah. Okay. Now I'm going to step this before even we do for the other ones, just to make sure. Okay, so pixel p, we're testing what pixel? Oh, we're testing the very first pixel. Yeah, okay. And we have 0. So we're probably wrong. Now let's do that again. Okay, so A. So this is the first point. B. This is the second point. Let's see. Yes, this kind of looks correct. Okay, now let's do the dot product. So we have 1, 0, and we have, okay, so that wasn't correct. We have minus, I was expecting 0. Oh, because we are rotated. Oh, I'm not going to pass rotation yet, just so it's simpler. Okay, let's do it 0. Okay, again, let's do it. Okay, so now we have 0, 0, and we have, I suppose we were just wrong. Our rect, let's say P0 is this one. Yeah, our rect is pretty wrong. Let's see. We have min and we have max. This should be like min x and max y. I think, yeah, I don't know why we did that. This should be min x, max y. This should be max x and min y. Today is like a weird day, but it's a math day, so it's probably why it's a weird day. Okay, so okay, these look better. Okay, let's see. Okay, this is correct, I think. So we should really have a. Could you explain why you're using two IDEs? Do you use? Yes, I'm using Visual Studio just for the debugging, and I'm using I'm using ForCoder for text editing. So yeah, and I compile in here. running with Alt-M, which we set up that on the first day. So yeah, that's why we're using two software. So the dot product turns out to be 0. I don't think that's entirely correct. Like, oh, because we are offsetted by the min. So this really should be this really should be the pixel p plus the min. The min is like the origin. Let's put it that way, since we are using that as origin. So yeah, we are going to have to like do a another pass on this later on. Okay, is it convenient? I think it's pretty convenient. I mean, I can Alt-Tab pretty quickly, and I think this is a great text editor, and I think this is a pretty good debugger. So I guess I get the best of both worlds, because I don't like this text editor at all. I don't like it. So I think I get the best of both worlds doing this, and it's not inconvenient, I'd say. Okay, so the pixel p, yeah, maybe this is a little bit better. Let's see. So we are huge. This is not correct. I expect it to be hugely negative. So let's see the values we got to understand the program a little bit more. So we're subtracting 500, which is the minimum p. Yeah, we should actually be doing the other way around. This guy minus this guy. This is true. I think the VS is one of the greatest debugging systems. It does, especially when you compare it to like Linux with like command line debugging. Come on, guys. Really, yeah. So I really like the debugging here. Okay, so let's do it one more time. We have A, which is this point. Like, let me draw. It's this point. Oh, but we are right, because we were subtracting. Yeah, we wanted this axis. So I suppose we were correct. And B, yeah, so this is not going to be right. We were right. So this guy is negative. It should really be positive. We are respecting this guy. Okay. Again, let's do it one more time. The problem is in our dot product, really. So we are dot. Actually, I think the problem is. No, the problem is really this guy. Yeah, the pixel p. Yeah, this guy, this pixel is like up here. These guys aren't in pixel. So let's say this guy returns a vector like 0, 400. And we want to know whether or not we are on this side. And to know that, we are projecting this pixel onto this guy. Yeah. Let's understand that one more time. So we were working pretty much until we started doing the dot product stuff. So let me take this guy back and go back to this point. Okay. So we are working, okay. But we want to do that with the dot product. So the basic idea is, let's say we have a pixel that we want to test, and we have these points. Correct? Yeah. This vector, oh, maybe I should offset that by the minimum guy. or just subtract. Yeah, I think the problem was this. Let me go back once again. I think the problem was this guy. I should really subtract because, yeah, I don't want to push him further. I want to pull him back by this amount. So I'm going to subtract the pixel P, which is this guy, and this guy. Okay, this looks a little bit better. So let's see what we have. B, okay, so this axis as we expected. P is like 0, 0. We expect that to be on our left, x-wise, considering this is still axis aligned. Yes, and now we have minus this guy. Okay, I think we are getting somewhere. So we're going to do the same thing, like this is the dot, yeah. And the same thing for the other projections. So we do this guy, which makes sure that we are on this side. Then we do the other guy, which is this one, that makes sure we are on this side. But it is the other way around, right? We were doing pixel minus min. So this is actually the other way around, but negated? Is that correct? Well, let me just step in and see what we have at the other guy. So, first one, we get minus a huge number. Okay. The second one, we expect to get positive huge number. Then we do. So I think we are getting somewhere. And now we do the same thing for the y, which is going to be 0 and 2. Okay. And now let's see what we have. We expect, let's see what we expect. We expect negative huge number, positive huge number. And those are the two that we tested. Here we expect, we're testing, let me go back to this image. We're testing now this axis, right? So when we project against, so we expect, again, positive huge number and positive small, negative huge number. We got the other way around. But yeah, I think I was just confused. No, I wasn't just confused. This is really wrong. Okay. Okay. Let's see. Why do you have the statement inline v2? How do you understand this? I don't know. Inline, I usually put like either internal, which means static, because this is a Unity build. So I put internal in everything. So if you go to like Windows, like internal, well, I have one in Windows. If you go to game, internal, yeah. So it's pretty much internal and the return type. So that's the basic thing. And here, instead of internal, I'm doing inline and the return type, inline v2. Not sure, it's pretty easy to understand, I think. Okay, let's go back to our debugging. These two guys look correct, I think. Oh, I should really start from scratch just to make sure that we have like the 0, 0 guy, which should not be included. Well, it's not going to be included because this was negative. But let's just check out this guy. So we are passing 700, 400, and 500 Yeah, so this is wrong. Maybe I should, yeah, I should do it like this. No, you know what? This is better. So we are doing like a counterclockwise definition for the rect. Like, let's come counterclockwise points. Thanks. No problem, man. Okay. So if we are doing counterclockwise points, let's go back to the rendering. We should not do like 2, 1. We should do like 3, 1. 3, 0, pardon me. Okay, so we got this vector. We were getting this vector. Okay, let's just see one more time. Okay, we're still wrong, but we are very, very slow now, which is not unexpected because we're testing like everyone. But we are going to, yeah, we're going to fix that later. But now let's debug that one more time. Let's see. Okay, so we have 700 and 256. Okay, then we have 500 and 270. This is still not correct. It's either oh, okay, so I was expecting 2, which is the max. That's funny, that's what we had last time. So this guy, which is like, let's just check out the min, is minus and minus. So the min is this guy. And we do the min for the 0 position, and then we do the min. Oh, okay, we do it like this. So okay, 1. Okay, so that's okay again. We do it like the min, and then we do the max and the min. Then we do the max, and then the min and the max. Okay, and this guy should really be the min and this guy. Let's see. Let's see what we have. Okay, let's debug one more time. Yeah, math stuff, if you don't get like 100%, turns out to be really finicky. Let's just see. Yeah, this is correct, I think. So our sub is 500, 400, 500, 200. Yeah, looks about right. So we should have like a positive vector on y. Is that correct? Let's see. We do have a positive vector on y. Yeah. So we have okay. But I don't think we hit this at all, do we? No, we don't. Let's just cheat and go through the guys we know should. Let's just start with the guys we know should be hit. So x0 and this is 1. So let's debug that. Okay, so now let's see. The x is this guy and the y is this guy. Okay. And now that we added the base, there are these weird numbers. I wonder why. They really should have been exact, I think. Let's run through these guys. So rotation matrix should be 1, 0. Yeah. Okay, so the min is minus 10. The max is 10. Okay. Aspect. Okay, yeah, because we changed the pixels, so it's gonna be a little bit finicky. That's okay. Yeah, so yeah, we expect a little bit of an error. So let's run that a couple more times to have. Okay, so this, we expect this to be correct because the pixel is 564 to 72. And when we subtract the origin, we have a positive guy. Oh, you know what? We should have like a positive on x and y. So I'm going to do it like this. Okay, now we should have a positive on x and y. And we do. Okay. Now, we're subtracting the first guys. They are equal in y, different in x. Okay. Now let's do the dot product. That's the part that we're probably getting wrong. So this is this guy, and this is a positive x. So this should be positive. It is. Now this guy, let's see. $772. Okay, so this should be. I think this is gonna be negative, right? Negative x. So I think these are wrong. Yeah, these are wrong. We are testing these guys, this guy, and this guy, but we offsetted the point based on this guy. So this really should be just this guy, the pixel P. Okay? Now, if we do that, we should really offset, I'm sorry, yeah. I should really offset this guy by this guy. And then this guy I should offset by this guy. Because since we're starting out here, it should be positive means this way. Yes, I think we are, just like the collision stream, we have to do like, we really have to do step by step so we can understand the full thing. Okay. Dot v2, too few arguments. Oh, I got two substitutes. Let me just go back. I got that wrong. Okay, so this one is going to become this guy, passing free. Okay, let's just see. Oh, okay, and we are back. Normal. Okay, and let's not cheat. Let's do the whole thing. We're gonna be super slow. Yeah. Okay. And before we do the jump, in fact, this should already work because we are getting the subtraction as the axis. See, these guys, I can really calculate them up here, and we're gonna do that. We're gonna optimize this later on, but just check out. I think this may work. Do you guys think this is gonna work? Do you guys think that if I put angle here, this is gonna work? We expect to see a rotating rectangle. I don't know. We are wrong, but our multiplication is wrong probably. Let's do like 45. Let's see what we have. Let's do 10. Yeah, these guys, let's do 45 again. And let's go again for these guys. Okay. So the max and min. Yeah, this is wrong. Let's go one more time. So our angle is 45. Yeah, our angle now is in radians. Okay, our P is 0 and our size is 10. Cosine, sine, minus sine, cosine. This looks correct. Our rotation matrix looks correct. But this guy, minus 10 and 10. I don't know why we have 0. Oh, okay, no. Oh, okay, this is correct. So we have 0, minus 14. And our max is 0, 14. You know what? We can't do this. This is messed up. That's why we got confused that for a while. Let me just find out what I'm talking about, the rect. We can't do this. We should do, actually we can, but we should do this like up here. Then we multiply each axis, each point individually. Yeah, I think this is correct. So it's going to be rect. Let's do a for loop. Four points. So we're going to multiply by the rotation. What libs is used for rendering? No, we're not using any libraries. This is the thing. That's why we're having such a hard time having rotated rectangles, because we're doing all by ourselves. See, this is actually setting the pixel color by hand, so no libraries. And we did a lot of stuff. We did alpha blending already, but now I don't know if you saw the state. That's the state of the game. Oh, we got that huge thing. Let's just remove that for a while, just to show you the state of the game. Can I just return it if 0 these guys? Okay, so this is the game that we have so far. And everything was written from scratch. And today was the first time that we used the library, which was the math library in the CCN library for sine and cosine. But the rendering we did ourselves, the collision we did ourselves, the particles we did ourselves. So yeah, I think it's gonna look a lot better when we do more stuff like this. But it's turning pretty cool. Interesting. Could you show the code how you create the graphics window? Sure, but if you want to come here to YouTube, and I can link it to the YouTube page, you can check out the whole process. We started out with the blank file on episode 1, and I recorded all the streams. So you can watch the whole process, the whole file process. But really quickly, we are calling Windows stuff, right? Because this is Windows. So we create a window in Windows. That's it. We just create a window class, and then we call create window. And then this is like for mouse stuff that we did later on. So we gather input. This is like input from Windows. Okay, and this is the rendering. So we show, we say Windows, hey Windows, this is our pixels that we allocated up there. These is our pixels. This is the size. Show to the window. So this is the call. That wasn't too hard. In fact, I've done that a lot, so that's probably why it wasn't too hard. Since I haven't done this a lot, that's why I'm having a little bit of a hard time, but we are getting there. So we're doing the rects, right? Yes, this guy. So I'm going to multiply each of the rect dot p and I. like this. Okay. Now I'm probably going to do a make rect center center half size, right? So yeah. Yeah. Okay. And the min is just the rect 0, p dot 0. So this approach of manually setting the pixels is fast. What do you think? I mean, it's way slower than the GPU. That's for sure. If you wanted to do like the fastest render possible, we wouldn't do that at all. But I think it's gonna be fast enough for this game, and that's the point. If it's fast enough for this game, and we can learn a lot about graphics programming by doing things without the GPU, so we know the whole process, that's worth it. And it's also, yeah, I think that's the point. It's going to be fast enough for this game, and it's also a pretty good learning exercise. I think I deleted something. Yeah. Okay. Okay, so we don't have that. Let's make that. So we have a inline rect 2 make rect center center half size. This is the center. This is the half size. And same thing here. But the min is the C. Well, yeah, you know, in fact, I'm just going to call it up the other guy. I'm going to return make rect Minimax. And the min is going to be a v2 of the center minus the half size. And then this is going to be an addition. That's the max. Okay. Now convert this guy to a float. Okay. Yeah. That's just like this. Min. Yeah, and I think we have to do the same thing here. I'm gonna optimize this later on, but this is just for our debugging points. Okay. Okay, then we add the P. Yeah, this is pretty stupid. So even for a software renderer, it should be slow. This is stupid. I may be wrong, but the Caro lib do the same. I'm sorry, I don't know that lib, but I'm sure there are a lot of libraries that do software rendering because it's great for learning, and it's really easier to debug, especially when you do like more advanced stuff. Way easier to debug. So whenever I see min, so I think this is going to. Are we using this? I don't think we are using this at all for now. Okay. Oh, we are. This is just 0. Yeah. Let's see if we still see the same thing. No, we are wrong. Our rect's way over there. So that sucks because we got to a nice point, but in order to clean up to the next part, we did all sorts of. So we could have messed up in a lot of ways. So I can just go back and see that we don't have. Oh, so we are totally wrong. First of all, I can just pass 0 again, but even our points were wrong this time. So yeah. let's just quickly understand the code here. So this shouldn't matter. So this should matter. Okay, so we got the dmin and dmax. That's weird. Because this guy, the dmin and dmax, is what we were using for the points, and that messed up the points. So I think our rect is wrong. So center minus the half guy. Oh, we're doing max min. That's not very intuitive. Minimax. Yeah. Just mentioned you're using a C++ Litecoin instead of C. Yeah, I am. I think it's easier to do that. You know, I wished there were a couple of C++ things in C. Just a couple, like default arguments is a big thing for me because I think it makes life really easier. But this is C, so I do some C side comments as well. Okay, so let's see. Yeah, we are still wrong for some reason. Our points. Yeah, let's debug again. Here. So first of all, we construct our rectangle, which is 10, 10, 10. Yeah, see, it's wrong. We're supposed to be minus 10, minus 10. Min max. Come on. That's stupid. So do you have any other projects in C? Yeah, I do have. I've done a lot of projects in C. I've done like a web server in C. I did computer programming language in C. I did a few other games in C. If you go to the HIO, you can see the other games. Like, yeah, these two were in C as well. This was C++. This was using Unreal Engine. So yeah, I've done a couple of things in C. Not too much though. Okay, min max. Start out with the min and go to the max. Let's debug again. So now this should be minus 10. It is minus 10, 10. Then I expect it to be minus 10, 10. Dude, this is, yeah. Min x, max x, min y, max y. Okay. Programming language like C, Python? I don't know what you mean. C, just these projects were in C, yeah. Just good old C. Yeah, these Rects are really wrong. I don't think today is it's a good programming day. But I really want to finish this guy. So 0 and 10. So this should be, oh, okay, I wanted to step into that. So this is minus 10, minus 10, minus 10, 10, 10, 10, 10, minus 10. This is nice. So we should really just do that. Yeah. So minus 10, minus 10. Oh, we're just getting the P. Oh, but it is. Oh, I'm sorry. I thought I found the problem. I didn't find the problem. So the P0. Yeah. These are the stupid mistakes that takes a long time to track. Okay, now we should be back to normal. And we are not back to normal. Well, because these guys, I suppose, were correct. See, the problem is when I don't fully understand 100%, I saw a meme the other day. I just tried a lot of different stuff, but let's draw, and you guys can understand as well. So, okay, we have now the rect minus 10, minus 10, minus 10, 10, 10, 10, 10, minus 10. No, actually, this was correct. Okay, so let's do it one more time. So minus 10 minus 10, we have 10 minus 10, 10, 10 minus 10, 10. Okay, this is what we're supposed to have at this point. Let's check out. Minus 10 minus 10, 10. Okay, this is what we have. Now, when we multiply the matrix, the rect should be, let's see, we have the bottom point, and then we have the top point. Yeah. See, we did all the stuff to get to this point, and that's not correct. We are multiplying each of the points by the rotation matrix. Oh, you know what? Not that this is going to matter for now, but this guy should really be 0. But we are 0. But if we weren't 0, it would be all over the place. Let's just see what will happen. I mean, we are all over the place, so not that we are incorrect, but let's put like random numbers there. We'll add sound. Yes, we will add sound to the game. And hopefully we'll do that when we finish this rendering pass. How am I going to do that? I'm going to implement direct sound, which is like the Windows library. And yeah. They're going, yeah, pretty much on it. And then the mixer we're going to do by hand. Okay, so we make the rect. Yeah, I'm not going to worry about the P for now. It's going to be wrong, but we're going to correct that later. So I don't know why we got that wrong. Man, this was supposed to work. What are we not understanding about the program? So I'm passing minus 10, minus 10, 10, minus 10, 10, 10, minus 10, 10. Okay? Okay, let's check out the rect here. So this is correct. This is not correct, I think. Oh no, this is correct. Oh, I got that wrong. We are correct. Dude, we are correct. So, in fact, I'm going to save. Yeah, this is wrong. This is why we're not correct anymore. Rect 2, rect, suppose rect, and then we do like. Okay. So we are changing the rect to be better, and we had the old system. That was wrong. Okay. Okay. Nice. We are back to having that. Let's see. We're back to having the angle working. See? Oh, and we do have some weird behavior there on the left. See? So we're getting there slowly, but we are. And this doesn't matter for the player, right? All it matters is that we managed to make it. But it does matter for our learning process. Just it's nice to make mistakes at this point. Okay, so we got to this point, and then we changed that to the screen aspect ratio, to the screen position. right? We multiply and we add. Okay, now let's check out these guys. We have the pixel position, and then we do the let's debug. I'm working in the university and doing the particle shapes properties calculations. See, but what you're doing is amazing. Maybe I'll do some concepts you're implementing now. Thanks so much for sharing. Dude, no problem. I really liked that you liked. And check out, we did particles the last couple of streams, but the last stream was the big particle stream. So you can check that out on YouTube. And if you have any question about what we did, that went way smoother than what we're doing now. But this is going to help the particles, because right now, it's going to be kind of hard to see. The particles, they don't rotate, they just move. So when we add, well, it's hard to see. Yeah, it's you can kind of see there. Yeah, there. We're going to add random rotations to the particles. So that's going to add the visual appeal a lot. So let's debug these guys. Okay. So the pixel, all the way to 0 pixel, right? This guy's really negative, really positive, really negative, really positive. It's going to take a while. But let's see why the guys here on the far left were correct. Okay, so the projections all worked, and the pixel P looks correct. Oh, okay, stupid mistake. We should increment the pixel even if we don't. Oh my god. Even if we don't paint them. Oh, victory! So we finally managed to add the rotating rectangles. That was pretty neat. So what we're going to do now is clean this up, optimize this up, and then maybe add that to our particle systems. And now saying particles, I mean real particles. Oh, okay. You're talking about like physics particles, not explosion particles. Yeah, I know nothing about those. Oh, that was pretty funny. You must have thought, okay, this guy's pretty crazy. Okay, let's just see up close what we have, because, come on, that was pretty cool, right? What we may want to add later on is actually subpixel accuracy, so we should have like a smooth border here. Even Paint does it, see? Yeah, we should add that later on, but I think we are perfect for now. I mean, yeah. So, a couple things we're gonna clean up, right? First of all, we don't need to do that anymore. So let's just destroy this. In fact, no, I think we can destroy that for now. And okay. So we're going to optimize this, which is the main. Are you talking about anti-aliasing? Yes, exactly. But we're going to add like I think we're going to pretty much hack anti-aliasing. We're not going to do like a full anti-aliasing. I don't know if that makes sense or not. We're gonna try a couple of things. But yeah, let's see. This is the main problem, right? We are doing like repetitive things like over and over again. We can probably save this guy and this guy. Oh, yeah. So this guy, I'm gonna call that axes 1, 2, and 3. So like axes 1. We can do like axis 1 equals this guy. Gonna do axis 2 and 3, and 2 is 0, 1. The other one is 3, 0, and 0, 3. Okay, these are the axes we are going to test against. Okay, dude, that was pretty cool. See, once we get to work, which is the hard part, cleaning up's way easier. But that's kind of obvious, right? We can also, let's see, we have an extra guy. Okay, let's just make sure we didn't break anything. And we didn't. Pretty cool. Pretty cool. Oh, we should also do like draw rotated rectangle, transparent rotated rectangles for the particles. But one step at a time. So, first optimization done. Second optimization, this guy. We can do like the relative, and we could also do the particle relative to the same point. But yeah, I don't think it will matter much. So pixel. Oh, this, yeah. Okay, yeah. So I'll call this pixel p rel 1. Pixel p rel 1. Then we're going to do 2 and 3. So this is the pixel rel 2, and this is the 1 again. Pixel rel 1, and this is the pixel rel 3. Okay. Let's see. We are still working. Nice. And okay, so in fact, now we just run a lot better, to be honest. I mean, not a lot better, and we're still pretty bad. And our player gets way out of hand when we are in a slow frame rate. Let me just check out why. Just a second. Let me see, where's the drop player? Here. Let me see the target position, just so we can see if there is actually a movement problem or a scale problem. Yeah, this is actually maybe a scale problem. Yeah, it is a scale problem. So I'm not going to fix the scale now, but I'm going to write this down in the let's see. Yeah, this guy, fix player scale at low frame rates. Okay, let's go back to our, and this is pretty much as succinct as I can make it. Now, this is also a problem because we're going through the whole screen. And we don't need to do that. All we need is like the smallest guy in here. And we can also optimize this, but I don't think this will matter much. So in order to do the smallest guy there, all we need to do, let's do it like this. So this is like the min. The min bound. Yeah, and the min bound is going to be 0, 0. Do we have to do inside the main C file? Why not somewhere else? I don't know, it's just more convenient. This file is like 1100 lines. So I'm not afraid to put a lot of stuff inside here. This is way more convenient, I think. Don't you think? I mean, it's already here. I just, I don't know. Sometimes I do a to-do file, but max bound. But only if it's like a bigger project, I think. Render buffer height. width. Looks nice. Thanks. Yeah, I don't know. I don't think it's like the most organized thing ever, but it's somewhat organized. So we have the min bound and the max bound. So when we calculate the node P, we do like if this guy dot x is less than, I'll just truncate. I should truncate the yeah, I'm gonna do like a truncate x truncated. I don't think we have truncate, do we? Let's do like line int trunk. And then I'm going to return a, and then I'm going to do the seal. A plus 1. We also do like a round. Yeah. Oh, see, that's why I don't like important libraries. They already have a seal. Seal F. Trunk F. They also have a trunk F. Truncate F. Seal F. They have seal and seal F? Come on. Let's just use theirs. But yeah, we learned how to do it. Okay, so let's do a trunk of my seal. I'm not gonna name it my seal. I'll just accept the defeat. Dot x, and let's do it like dot y. Then we do for the seal. Seal. Yeah, I'm not sure how they typed it, so double to int. So it's supposed to be trunk F, right? Float to int? Dude, what's the problem? Truncate F? I'm gonna do my version. And I might as well call it my seal. No, I'm kidding. So I want to truncate. Let's call it truncate F. This is C, no namespace. Yeah. Yeah. Well, but they're not supposed. Well, if they are doing a library for C, and they know it's not namespace, they should prefix the library. It should be std underscore seal. So, yeah, it's not C's problem, it's their problem, I think. The library problem. So it's going to return int a. I'm going to do like F32 and break my pattern just so you can get a seal F32. So I'm going to do it like this. Okay. So trunk F32 and seal F32. Okay, nice. Now we can test if the truncated version of x is less than the min bound dot x. The min bound dot x is going to be equal to this guy. Then we do that for all of the other stuff. Max and max. Y. Oh, this is correct. No, this is not correct. If the max bound is greater than the max bound, if the min bound, then we do the max bound, This should be y. Yeah, and this should be the seal. Okay. Now that we have this information, we can optimize this, and this is going to run way faster. Let's do like y, c. No. This is the min bound dot y, and this is the max bound dot y, and this is the min bound dot x, and this is the max bound dot x. Okay, let's just run this code. So we get the minimum and maximum bounds. Yeah, this looks correct. I'm going to step this code because this is kind of a big deal optimization. So if this isn't working, we're gonna have like some headaches later on. So let's see, we are supposed to draw, let's see, we're supposed to draw these guys, 563, 272, let's see our minimum bounds, 0, 0. So I think the max is working. Max x is 700. Yeah, max x is working, and max y is also working. No, it's not working. So we messed this up. If the truncated version of x is less than the minimum, that's the new minimum. If the seal version is greater than the max, oh, okay, found the problem. So see, thank God we no, this probably was going to work. So thank God we fixed that in our debugging thing. Okay, now let's see. We have our minimum is still 0, and our maximum. Now we're super wrong. Did I do like everything wrong? Max bound x. Max bound x. Min. Yeah, F32 is just 32-bit float. Yeah, like just I think it's easier to type, and it follows the other pattern for int as well. X, dude, this should be easy code to write. I don't know. Today is pretty slow. So the minimum bound is 0, and this guy x tx. Okay, so the problem was I initialized that wrong. So the minimum bound should be this guy. Yeah. Yeah. I don't know what I was thinking. Yeah, this may be assigned to. Is it safer to use this instead of double, for example? Safer. I don't know what you mean for safer. I mean, you use double when you need a lot of precision. And like let's say you're doing like a movement system for a game, and you store the x and y position in double, and you go all the way from 0, 0, which is like the center of the world, which you have huge precision, all the way to like 100,000 kilometers the other way, right? If you want like centimeter precision, you're probably gonna use double, or like break up the world in segments and things like that. But that's the use case for double. Not safer, I think. So I'm not entirely sure what you mean. So the minimum bound x, let's see. Okay, I think we are correct. we expect the minimum bound x to be 563 and the maximum to be 700. 563 and max 701. Actually, this is correct. And then the minimum y we expect to be 272 and the maximum 409. So 272, 409. Now we're talking, and now we should run pretty smoothly, and we do. Oh, but we are wrong. We are wrong. Okay, we are wrong because of this guy. Yeah, we removed that when we did the whole screen. Now I can put that again. Okay. Oh. Min bound x. Okay, we are back to normal and we are running pretty smoothly. And this is the debug build. So if we build that on the normal build is going to run even faster. So this is pretty perfect, I think. Yeah. Let's go back to the rotation, which was the whole point of today's stream. I think we're going to keep just that rotation, and next time we can do bitmaps, and then we do like an anti-aliasing if we need. Safe means, for example, if different compilers can take different number of bytes. Yeah, I know what you mean. Like for some platform that, yeah, like in some platform, maybe int is not 32-bit, like then we do it like this. And maybe float isn't 32-bit. I don't know. I mean, if this game was supposed to last like 10 years, I'd be a little bit more worried about that. But it's also easy to change. But no, I don't think there's any platform that C compiles to that float is not 32-bit. Well, maybe some like I don't know, embedded device, but yeah, I'm not too worried about that for this project. Perfect. Is it not perfect? This is perfect. Now we should play around with this. Just in fact, just one more thing that maybe we can optimize. This whole thing here. Not sure. Like speed, cleanup, maybe do a single matrix transform, multiplication. Yeah, I don't know. So let's now start using our guys. So I'm going to do in our particles system, let's see, draw render particle. Render particles. Let's do a draw transparent rotated rect. Then we can do a P angle. Okay, and for transparent, we can just copy that. Okay, alpha, and we should also take an alpha. Like this. Okay, undefined. Oh, yeah, you know what? I'm only going to do draw rotated transparent Rects for now. Transparent rotated Rects. That's a pretty bad name. I gotta think about a better name later on. And then we're going to add an angle here. And yeah. Okay. Okay, now let's do, when we spawn particle, we should take in an angle. So an explosion should have random angles. So I'm going to do random F32 in range. Let's do 0 to 360. And block destroyed should be 0, the angle. Actually, half size. And render the ball. Okay, this one's gonna be cool. I need, when we spawn the ball, I'm going to set, let's say if the ball is going this way, the ball is gonna be a square, but the particle is gonna be rotated. So I need to find like a find angle, something like this. What do you think? Should the programmer even in C pay a lot of attention to making the program smaller in memory during the execution? We have a lot of RAM. Actually, in the future, we have even more 32-bit or 64. Doesn't matter or not. This is the thing, in my opinion. Depends on what you're building. So, if you're doing like a console, like this guy, if you're doing like command prompt, you don't want to spend like a whole bunch of RAM. You don't, because people are going to run like a ton of these. I'm just going to leave this guy running like I'm doing now. So, like, don't use like more than you need. That's the main point. Don't use more than you need. However, when you're doing a game and you're expected to be the main thing, if not the only thing the player is running, so you should be able to use this memory, right? So you are free to use that. You should not use it for no apparent reason, but I think you should use that reason to make the game better. So if to make the game faster, or maybe avoid loading screens, and yeah, so I think depending on the application, you should really use this RAM to make it better, but not lightly. So yeah, I think they should be aware, but not to make it smaller necessarily, but to make it use it more, I don't know, more interesting in terms of for the user, I suppose. Yeah, okay. So I'm going to do like a find angle. I'm going to make it like find look at angle. This is Unreal's name for this function, but they return like a full quaternion, but this is like 2D. So find look at angle, and I'm going to pass the the speed, right? The ball dp. And actually, before I do this, I'm going to pass 0. Getting kind of ahead of myself. Let's see if we run. Yeah, we see particles, and we run pretty well. Oh, we have to clamp the alpha, like we did. Transparent. Yeah, I have to clamp the alpha. Let's see, that's the only thing we do here. Okay. So, back to normal, I suppose. So now let's do the thing that we worked hard today for like 2 hours to do. That's the radius vector. You can show the director of the particles moving. The radius vector. I'm not very a math guy, I'm sorry. I don't understand much math, so the radius vector, what exactly is the radius vector? I think I'm just going to pass the speed, is it not? Can show the direction of the particle moving. Yeah, I think that's it, I suppose. I'm not sure though. Oh, in fact, we are supposed to have random particles already, are we not? I forgot about that, and apparently we don't. Oh, because we don't set it. Yeah, the spawn particle receives the base here, the angle, and we should really set it. Radius is the vector that has the initial point at 0, 0. Nice look. Thanks, Great bullet, DE. Yeah, so we were talking about the same thing. Yeah, but I didn't know it was called a radius vector. So I have like two vectors. This is like the old P and the new P. Let's say it's going like this, right? If I subtract these guys, I get this vector that is pretty much, yeah, it's this vector. So the other two are points, I suppose, and this is the actual vector. I'm C++ programmer. That's awesome, dude. C++ is really cool. It's pretty much like C, except it has more features. Some of them are pretty cool. Some of them are pretty confusing. Watching my enemy. You're watching your grandfather, actually. You're watching the wiser version of C++. Okay, so we're going to do the find. Okay, no, actually that's test. If we got to work and we are super wrong, okay, we are super wrong in several ways. If it's easier on, or more direct, how you see, yeah, I like C because the code is way more direct. So I don't know if you guys remember, but we had a problem that I postponed. Now I have to fix the problem. See the particles were all over the place? That's because of the order we are doing the matrix stuff. So we can't, we can't do this guy here. We first have to rotate. Then we should add the speed, like this. Add the position, add it to P. I have a problem with public space tried multi-threading. Okay, yeah. I kind of missed the chat. I use C2 if it's easier. Your name is Python, maybe, but not C. Yeah, we're gonna do multi-threading when we do audio, you know. Okay, dude. Okay, this is not correct yet, but it's getting correct. So another problem is we should add this guy, the P, before we multiply. Yeah, we should really do like a full matrix. Yeah. Which is this guy. We first add, then we multiply, then we do the other position. So yeah, not entirely happy with the way this is structured, but it's good enough for now. P is not a member of V2. What's the input event? You can make much more fluent the polling on a separate thread. A good idea. Yeah, since this game's gonna run pretty fast because it's a pretty small game, I don't think I'm gonna do like the polling on a different thread. This is how I'm getting the input. I just, at the beginning of every frame, get all the messages that Windows sent me and check for like key stuff, and then get the mouse at this point. I'm gonna use threading for audio, definitely, because that's really important. And also probably rendering, depending on our performance. But I am going to check check the performance before we do that like profiling. Oh, see how cool is that? I think our explosion is wrong. Particle explosion. I think our explosion is wrong in this sense here. So random bilateral times 10% times the base size. Yeah, see? It was wrong. You have a really nice style. My size should. Thanks. Okay. This is starting to get nice. The life or the explosion particles are still not very interesting. So life is going to add a random bilateral, which is -1 to 1 times 10% of the base life. That looks about right. Let's not do that. Let's not do that either. Let's see what we have. Do write everything in one line. I will show you my code, of course, okay. Yeah, see, now the life looks consistent. So does the size. So this, I suppose this was supposed to be pretty easy, right? I'm going to add to the size a random number that's 10% of the base size. Then I'm going to add a random number that's 10% of the base life. Or maybe the life, oh yeah, I don't know. It's easy to simulate important things in separate strings. I don't know what you mean. Yeah, I don't know. They kind of look bad, I think. Let's try the space invaders. That's pretty cool, man. Starting to get nice. But before we try to fix the explosion, let's just do the on particle. Let's do the find look at rotation thing. So this is going to be the angle equals find look at rotation, and then I'm going to pass, well, yeah, I'm going to pass the ball dp. I'm going to pass like up. I should also do like get vector rotation. Yeah, I think that's going to be better. Then I'm going to print the angle. If you have a certain space in string for, okay. Yeah, then I'm going to do like, where do we have like degrees to radians. So I'm going to do an inline F32 get vector rotation, and so what I want, let's see. Yeah, it's like the arc. Yeah, I think Jovis is going to know this better than I do, but I want like the 8, 10, 2, right? Yeah. The arc tangent. So, do we have the arc tangent? Let me see again. Yx. So, b dot y, b dot y, b dot x. But we need more stuff, right? Missing parentheses before v. What is that supposed to mean? I like your code a lot, thanks. The first part, there's no problem, dude. It's all good. You don't have a v2? No, we don't have a v2. Yeah, okay. Your C looks superb. I thank you. Okay, so we got 1. Yeah, okay, nice. Now let's do the arctangent thing. That's the arctangent. But we need the arctangent. Conversion from double to int. So we have the arctangent. We do. Maybe it's gonna work. -1, 1, 2. Yeah, this I think this is in radians. Let's do like rad to deg. When we do like deg to rad, let's do the other one. Rad to deg. Here we take an angle, and it's going to be the other thing. It's going to be like okay. Okay, this looks perfect. Oh, come on, wait. I was looking at the particles. Okay, they look almost nice. See, this looks perfect. This is exactly what we wanted. Do that. That was awesome. But this size looks wrong. This side. And why do we crash? Pixel was, let's see, where do we try to render? Minimum bound is -1. Yeah. So minimum bound. Yeah, it should really be like the min bound x is going to be, yeah, I'm just going to clamp it. Clamp 0 to render buffer dot width min bound x, and a min bound y do the same thing, and then I'm going to do the max bound, same thing. So now we shouldn't crash, but our particles only look right if we are positive, I suppose. Oh, this looks right, I think. Okay, so this is wrong, but now this is right. Have to go to sleep. Good night, man. Have a nice sleep. So this is working. Oh, okay. No, this is also working okay. I don't know why we're getting like values like 1,000. Maybe it's because we're not normalized. Let's see the arctangent guy. Keeps getting better. Thanks, man. It does. Today we implemented rotated rectangles, so our particles can use that, but it's almost 100%. It's not 100% yet. See, in that case, it didn't work. So we're doing like some math here. So this angle is the arctangent xy of this guy. Arctangent returns the angle between the ray to the point xy and the positive x-axis. Confined to -pi to pi. Well, apparently this is not working, right? Because we get way more than -pi. Just to be safe, this is not it, is it? Let's play in slow motion. It's too fast for me. dt is times like half. Okay, we have 180. I suppose it doesn't matter, right? But yeah, we are wrong. So I think we are offset by 90 degrees. This is correct. See? Yeah, we are probably offset by. I'm not sure why. Let me see here. Oh, because our 0 is considered to be not turned to the side but turned up. Yeah, so we are offset 90 degrees. So all I need to do is like subtract 90 from this guy, I think. Let's see. Yeah, I have pretty weird numbers, but it looks correct. Yeah. Let's see. Okay, this looks perfect. Perfect indeed. And I think it's perfect now. Yeah. I think our trail is perfect. Now let's fix the explosion particles because they don't look too nice. Oh, okay, this is not correct. Huh. Let's do a little bit more controlled experiment on this guy. So find 32 angle. So I'm going to I have an angle. Yeah, I have an angle between, I don't know, let's say 0, 0 and the ball. And then I'm going to draw a transparent rotated rect. And let's do it like 0, 0. Let's do 2, 2. Angle. Let's do white. Let's do 1. Okay, this looks correct. Now let's see if you are going to keep tracking the ball. I don't know, man. This looks super weird. I think we are missing something. I may end up just cheating and looking at my other code base. Because I'm really tired at this point. But yeah, you know what? I think the problem is we are getting the other way around. So we should really do like find. I'm going to do like find look at rotation, and let's call that A and B. And then I'm going to sub these guys, B and A. Geometrical thing like this is complicated indeed. Yeah, I always get these things wrong. I don't have enough practice. That's why making this a lot by hand is good. Is a good exercise, really. Redefinition of A. Let's see. Do you have a day job? I do. I have a startup that does help students get internships here in Brazil. I do all sorts of stuff there, but mostly like the web portal programming. That's why I like programming C in my free time, because I don't know, web is not really fun. So yeah, I like to do games for fun. Okay, and then we do like the find, look at rotation. Then I'm going to this is the starting point and this is the end point. That's what I want. So let's see if now this is a little bit more correct. And what are you using for web? I'm using Node.js. PHP, no, yeah, I use Node.js. For no particular reason. I don't like them. I don't like any of them, honestly. But it's gotta be done, so I do it. I don't know why they rotate so much. Let's but the animation is pretty cool. Let's print angle. So 360, that's acceptable. Minus 360, kind of acceptable, should be 0. Well, the angle looks okay, to be honest. Let's do something else. Let's do like angle. Let's do static angle equals 0, just for testing. Then let's do like static counter equals 0. Then we do like if counter is greater than 1, counter minus equals 1. Then we do like the angle plus equals, I don't know, 230. Counter. Maybe the strange rotation can be a good feature instead of a bug. I don't know, man. This is kind of a fundamental thing. So let's see if we rotate 30 degrees every second. Actually, we do have to increment the counter, right? Okay. That looks about 30 degrees, right? No, in fact, no, I think this is wrong. Yeah, I definitely wrong. We had it like twice and it got to 90. Oh, we had it 3 times and it got to 90. No, I think this is correct. Huh. No, I think this is correct. Let's make it a little bit more frequent. No, yeah, this is correct. So our collision is correct. If we set our collision to so this is correct. So this is the problem. You know what? I'm gonna look just quickly for reference. Where did I do that? Math rotation. Angle. Yeah, it's pretty much what we did. It's actually exactly what we did. Maybe we got these guys wrong. Initializer is not a constant. Minus 360, 360. Yeah, this is like super weird. Come on. Red to tag. Maybe this is wrong. You know what? I think I'm gonna guess this is wrong. I'm doing, let's say if we are 90. 90? Yeah, this is wrong. It's the angle divided by 180. No, divided by pi times 180. 90 times 180 divided by pi. No, radians to degrees. So if we are pi, yeah, okay. Okay, so the problem was, I'm pretty sure, yeah, minus 90. Yes, I think we are perfect now, 90. The problem was our, yeah. Okay, look at that. So the problem was really our degrees to radians. We did that super fast, and we actually didn't think about it. There you go. Lesson of the day, don't do things fast, especially when you're tired. Let's go back to normal. Let's see if our square keeps tracking our ball. It does. And our particle trail looks perfect. Now this is way cooler, I think. Yeah, really cool. So we're almost done. Let's just finish the explosion. We do a random rotation, and we do a dB scale. Yeah, no, I think we are correct, in fact, but our life is too short. Yeah, let's add a little bit of life in the explosion. Yeah, so, yeah, this is way too short. Let's do 0.3. Yeah, I think 0.3 is going to be cool. Okay. Nice. And maybe this maybe this explosion shouldn't have rotation, random rotation. I don't know. Let's see how this looks in the other levels. And in fact, I don't really see the wall. I think the wall particle should be white as well. Yeah, let's see the wall particle. So ball, update ball, yeah. If we hit, we spawn, start doing the wall color, let's do white. Yeah, okay. Yeah, and this also should be a little more. Are you using to compile your code or in the Visual Studio? I'm just using the Visual Studio. I initialized for coder with this with the Visual Studio batch files. So I can do like CL to compile. And then when I press Alt-M, I run this build.bat file that runs the compiler. So for coder for text editing, Visual Studio to compile the a bat file, and Visual Studio to run and debug and things like that. Okay, yeah. Okay, I think we can call that a success, although it wasn't a very quick success. But we're not looking to do a game quickly, in case you couldn't tell, right? We're looking to do a game and learn a lot. And I think today we learned a lot. I'm going to review the code just a second. Today we learned a lot. We did mostly, let's do the rendering, mostly this guy, which was the draw, transparent, rotated rect. So we build up our rotation matrix, we set up a rect, multiply the rotation matrix, change back to the aspect ratio, and apply that, got the pixel bounds, and then we did the dot product projection. So yeah, I would say we had a good victory today. I can even go back to my to-do and remove RotatedRect. Next time we're going to do bitmaps, which now that we started doing this kind of stuff shouldn't be too hard, but you know, every time I say that's not going to be hard, it's hard. So maybe I'm going to say it's be super hard and hope that it's going to be easy. Let's just see how everything looks in this, oh crap. Awesome. Dude, these guys are really super cool. Super cool. Yeah, these particles effects are really cool. I think the size of the particle should be influenced by the size of the block. See, because these are probably too big, and these are probably going to be huge, right? Yeah. So I'm going to spawn explosion. We have a base size, so explosion, whenever the block is destroyed, we're going to do, yeah, let's get the block half size. .x. Let's see. Oh, I think I put that on the wrong argument. DP scale base size. So the DP scale is okay, and this is the base size. So it's going to be block half size. Maybe I should do like, yeah, I don't know. And half size X. Yes, thank you for the stream. It was a very fun stream. It was kind of a hard on my brain. Yeah, maybe I should divide it by 2 or something like that. This was the perfect size. So instead of, maybe I'll just get the Y. Let's see. So it was pretty fun. It was great that we got to work into a great point, I think. I really liked the point we got in terms of the rendering. Yeah, maybe it's a bit too big still. Let's see these guys. Now that's pretty cool. Oh, inverted controls. Nice. I don't know, maybe I'm gonna have to hard code the particle size, because I'm feeling that this is too small. Oh, thank God, I was saved by the invincibility. I don't know, I think I'm gonna keep it like this for a while. Yeah. Okay, so I'm going to post the game and the source code on itch.io. So if you come to danzaydan.itch.io, you can download them both for free. Just click on this link, the first game. And then you can come here and download each day's of source code. So you can download the first day and all the way through today, which I'm going to post now. And you can watch the whole thing on YouTube. So if you go ahead and watch from the very first episode, that we started with a blank file all the way to today, you'll be able to see the whole process, every line of the code being typed. So yeah, that's it. I hope you enjoyed this stream and also learned. I learned a lot, so that was pretty cool. And hopefully by next time we'll start expanding the render even more by adding bitmap support. Then we can make like a bitmap for the power up, which is going to be great for the gameplay as well. So subscribe to the YouTube channel as well. Thank you. Yeah, please do. The YouTube channel is Dan. The youtube.com/danzaydan. I'm going to post the link here just to make it easier for you. And yeah, and I'm going to post all sorts of stuff. I'm doing like these highlights as well. I don't know. That's pretty cool, but it was a lot of work. And also getting some clips. So thank you guys. Already subscribed. Thanks, man. Next time, which I think is going to be tomorrow, probably at the same time, maybe a little bit earlier, not sure. We are going to be back to do some bitmap work. And hopefully it's going to be a little bit smoother, but who knows. And maybe then we can do subpixel accurate rendering? I don't know. I mean, I don't think we need that for the particles because it's super fast. But for the ball and the player, I think that's going to be desirable. Yeah, probably. Okay, so thank you guys for watching, and I'll see you next time. Cheers.